we are going to do a little practice with permutations. And what you might have noticed is that if we have a permutation of n comma r, I call this n choose r. We have n items, and we are going to choose, and order matters here, right? That we're looking for distinct arrangements. R is the number of items that we're going to choose to use, choose to order. So I'm going to say the first permutation is 6 choose 2. And according to the definition, that's going to be 6 factorial over 4 factorial, which we know we can simplify using factorial. 6 times 5 times 4 factorial over 4 factorial is just going to leave us with 6 times 5, which is just 30. 6 choose 6. Well, this is going to be 6 factorial over 0 factorial, which is just going to give us 6 factorial, which I know is 720, just because I remember that. And this is, so we have 6 distinct letters, for example, and we're going to order all 6 of them. So that is just 6 factorial. 5 choose 1, according to our formula, would be 5 factorial over 4 factorial, which just ends up being 5 times 4 factorial over 4 factorial, which is just 5, which makes sense. If we have, let's say, 5 distinct letters, and we're just going to pick one, well, there are 5 choices that we have. 7 choose 0. Well, this is a little bit silly. Think about it. We have 7 items. We're picking none of them. How many different arrangements do we have? Well, to me, just one. We don't have any arrangement. But if we just follow the formula, this is going to be 7 factorial over 7 minus 0 is 7 factorial. So we do get the one that we would expect. If we move on to question 7, this is going to be a little bit different. We have the word moo, which is very different than fun because we have some repeat letters. So if I was just going to treat this as a regular permutation, I might say, okay, we have 3, we're going to choose 3, and that should give us 3 factorial, which is just 6 arrangements. The problem with this is those O's, that if I was going to, let's just play around with this. I pick arbitrarily M to go first. So my next choice is that either I'm going to have the first O and then the second O, or the second O and then the first O. But to us, they are going to be identical. I also could have something like M in the middle. And again, the O's are going to be changed, but they're going to look identical. So out of these 6 choices that I'm going to have, really, I can get rid of half of them. And I'm going to think about the fact that I'm going to divide this by 2. In fact, 2 factorial, because it's the O's that are the problem, the two of the O's. So in this sort of situation, there are 2 factorial ways for me to arrange those O's. 2 factorial ways over here, 2 factorial ways over here. So I end up just getting a 3, which also makes sense if you think about this. Really, if you're rearranging the letters in the word moo, the only question is, where are you going to put the M? In the first spot, the middle spot, or the third spot? And for the second part, suppose we have the word puppy. Well, if this was just a plain old permutation situation, or fundamental principle of counting situation, I have 5 letters to arrange, that should be 5 factorial. The problem is that out of that 5 factorial, we have 3 P's. So I'm going to divide by the number of ways, 3 factorial, we could arrange those 3 P's if they were indistinguishable. So this is just going to give me 5 times 4 times 3 factorial. So I know I'm only going to have 20 different arrangements. Here's another way of thinking at it. Another way of thinking about it is that, really, you're going to be filling up most of the spots with P's. Out of the 5 slots that you have to think of, really, you could just approach it from where do you put the U and where do you put the Y. We know that the U and the Y will take up 2 of those slots, so I could consider this as permutation 5, choose 2. I'm just choosing where to put the U and the Y, which in fact, again, would give us 5 factorial over the 3 factorial, which is exactly what we had earlier. Question 8, same sort of situation. So here we have the word asymptote, and asymptote itself has 9 letters, I believe, I hope. So I could have 9 factorial different arrangements, but for the fact that I have 2 T's. So I'm going to divide that by 2 factorial, because out of each of those choices, there are 2 factorial different ways for me to arrange those two t's. Question number 9 is very similar. I have 13 letters in the word parallelogram. So if they were all distinct, I'd have 13 factorial different ways to arrange them. However, as far as the a's are concerned, I know I have 3 of them. So I'm going to divide out that 3 factorial way. I have 2